All right, this video is going to cover 6-3 vectors in a plane, day 2. Got some odd problems picked out here. These are the even problems for the assignment, and I got some odd problems here that are adjacent. So if you're having trouble with one of these, you might have a little help by doing an odd problem. I've marked some of these problems in red. Of course, you can always go to calcview.com and visit our friends on there that solve these problems also, if you're getting tired of listening to me. Let's dive in. 43. Directions. Find a unit vector u in the same direction of vector v, and then verify that the magnitude of this unit vector u is in fact 1. Because remember, that's the definition. A unit vector is a vector of length 1. All right, now from the lesson, remember here to find this unit vector, that's just going to be vector v divided by its own magnitude. So vector v, that's just this negative 2 comma 2. And the magnitude of that, remember, since we have it in this component form, the magnitude of it is just going to be, give yourself a radical, square the first number, negative 2 squared is 4, plus square the second number, 2 squared is also 4. So that becomes a root 8. Negative 2 comma 2 over a root of 8. And let's simplify that root of 8. Root of 8 becomes root of 4 times 2. So that'll become a 2 root 2. And let's break it into two separate fractions now. We've got this negative 2 in the numerator, so that'll be a negative 2 over a 2 root 2, comma. We have this positive 2 here over the same 2 root 2. Now we can cancel out these 2's, these whole numbers, so there are 1's left in those numerators. And why not? Let's have good math manners and let's rationalize. So what we got here is negative 1 over root 2, comma 1 over root 2. If we rationalize each of those multiplied by root 2 over root 2, our final answer here for this unit vector u is negative root 2 over 2, comma positive root 2 over 2. So this is the unit vector u. It is in the same direction as the given vector. It would have the same slope, but this vector has one length. This unit vector has the length of 1. And they did ask us to verify that. So here's our unit vector. And to check to make sure this length is 1, it's not overly difficult. Let's give ourselves a radical. Since we're in this component form, we're just going to bring down each of these pieces and square them and add them together. So bring down here a negative root 2 over 2, positive root 2 over 2. First, we're going to square away the negative. A negative times a negative is positive. The denominator, squared, 2 squared is 4. Numerator, root 2 times itself, will be a 2. Same thing here, there's no negative to square away, but our denominator will square to a 4. Our numerator will square to a 2. Now we could reduce those, but notice we got a 2/4 plus 2/4. That is 4/4. Anything divided by itself is 1. The root of 1 is 1. Just like we were expecting to find, because the magnitude of our unit vector here should be 1. So we verified that our answer is correct. 47. Find the vector v with the given magnitude that goes in the same direction as vector u. Now, over the years, this is usually the one that people have the most questions on. They give us here the magnitude of our given vector, find vector v. Yeah, the magnitude of the vector that we want is 10, and it's going to go in the same direction as this vector u. So, some notation, we probably saw this somewhere in the lesson in our books. Here, I'm going to switch to black ink. Vector v, the vector that we're looking for, the one with this magnitude, is going to be equal to the magnitude that we want of vector v times the unit vector for u. vector u divided by its magnitude, the magnitude of u. So let's put in the info they gave us. Well, this magnitude of v, that's 10, times vector u, well, that's just one here in the brackets, the negative 3 comma 4. But right underneath it, we want the magnitude of that vector. So if I put a radical here, and I square each of these and add them together, negative 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So that becomes a root of 25. Let me just back that up and write it in there. Root of 25, or that's going to turn into a 5. So what we have is, let's put this 10 over a 1 times vector negative 3, 4. Square root of 25 is 5. So we can reduce here 10 divided by 5. That'll just turn into a 2. Distribute the 2. So our vector is negative 6 comma 8. Final answer. It has a magnitude of 10, and it has the same slope as this vector u. Number 51. In the exercises, the initial and terminal points are given. Write the vector as a linear combinations of the standard unit vectors i's and j's. These aren't so bad. Let's put this one up here. So we've got the initial point. We start at the initial and we go to the terminal. So first, let's write it in its component form here. Remember, we always subtract terminal minus initial. So this is going to be 3 minus negative 2. 3 minus negative 2 is 5. And then we're going to go negative 2 minus 1 more. That's negative 3. So now to turn it into its i's and the j's, we just put a 5, or after the 5, we give it an I. And we could write it like this, plus negative 3j. Or if you don't like the look of the plus and negative, we could just make that a minus. 5i minus 3j. And remember, this I is not the same as the imaginary component I. That's a different animal. Okay, initial point to terminal. So terminal minus initial, negative 6 minus 0 is negative 6. 4 minus 1 is 3. So that'll be negative 6i plus 3j. Number 57. Find the component form of vector v. Sketch the specified operations geometrically. So here is vector u. Let me underline that in red. Vector w is here in blue. The vector that we want, vector v, is equal to u. So that'll be a 2i minus j plus 2w plus 2, and then the w vector is going to go in here, I plus 2j. So the first one, there's nothing out here to distribute. Technically, we could distribute a positive 1. So we drop the parenthesis, 2i minus j plus 2i plus 4j after distribution. 2i plus 4j. And then we combine terms. We got 2 i's and 2 more i's, so we got 4 of those. A negative 1j plus 3 more is plus 3j. Let's see if I can come up with a sketch on that. Let's even do it like this. Oops. This one here is 2 comma negative 1. This one here will be 1 comma 2. 1 comma 2. And our answer point here would be 4 comma 3. So we did 57 u, so that would be 2 comma negative 1. 2 -1. So this would be the u vector. U. What are we doing here? 2w. Here was w, so if we distribute a 2 here, that'll be 2 comma 4. So over 2, 1, 2, 3, 4. Let's see here. What was that again? 2w. So over 2 up 4. So here they are as separate vectors. We have a u vector. This will be our 2 times w. But when we add them, I'm either going to add this one to the tip of this, and that'll take us out here to this point 4 comma 3. Or remember the parallelogram law or rule. Instead of going that way, we could add the u vector to the end of this one, and it'll also get us to the same spot. Is that our last one? No. In this one, find the magnitude and directional angle. Okay, let's see here. So the magnitude of vector v, for here, if we take it out of the format with the i's and the j's, that's 6 comma -6. So the magnitude of that, give yourself a radical, square the first term, plus square the second term. So we have 2 of those 36's, or that is root 72, or root 36 times 2, or 6 root 2. So there's our magnitude, and now we want to find the directional angle. First, let's be extra cautious and sort of graph this point. 6, -6, so we're going to go over 6, down -6. So here is our orientation in the plane. The angle, remember, we always start in standard position and go this way. So we're looking for a pretty big angle, somewhere between 270 and 360. Well, let's start doing our scratch work here. The tangent of this angle theta is going to be b over a, or -6 over 6, or that'll be a -1. -1. Now, a couple ways to approach this. If you punch this in your calculator, if you do it on a calc, punch that in, you're going to get -45 degrees. So this angle is -45. What does that tell us about finding the big angle here in red? You know, this red angle would be our theta. What we found here was our reference angle theta prime. So we could subtract 360 minus 45 and get that this angle here is 315 degrees. Or if you look on your unit circle for tan equal to -1, you will see that occurring up here in the second quadrant and also down here in the fourth quadrant. And you could just look at your angles on there and jump right to the 315 degrees. Okay, that's our last odd problem. I hope they helped.